Some argue that humanity won't start colonizing and exploring the solar system in earnest until it starts economically mining the mineral-rich asteroids. Science fiction has been putting forth the idea for years, but it has only recently been taken seriously as a possibility. With the purpose of mining asteroids, many mining businesses have even been founded as a result of this. But how near are we to making this fantasy a reality? The Earth's natural resources are finite, and sooner or later, earlier than later, considering the continual rise of the global population and consumption, they will run out, according to specialists, including environmental scientists as well as geopolitical researchers and economists. They include minerals and metals that are utilized in the myriad industrial processes vital to modern society, in addition to energy sources like fossil fuels, which are not only becoming more and more scarce, but also detrimental to the environment. Phosphorus, antimony, zinc, tin, lead, indium, silver, gold, copper, platinum, and cobalt are the materials we're discussing. All the minerals that the crust of the Earth currently struggles to supply to us in the proper quantity and at a reasonable price. The Earth's crust contains only a small amount of the most sought-after minerals, and once they are all mined and consumed, no replacements will appear out of thin air. Controlling the extraction and export of rare minerals already has a significant impact on the economy and relations between governments, and in some instances, it can lead to tensions and conflicts, a situation that will recur more frequently in the future. We have already seen, for instance, how China enjoys a significant competitive edge over other industrial giants because to its nearly complete monopoly on the extraction and trading of some essential minerals used to make electronic components, known as rare earths. There aren't many ways to stop the inescapable loss of some earth minerals. Reduce waste and create innovative industrial and mining operations that are more effective and use less resources, experts say. Recyclable materials must be employed in new processes, and everything that is no longer useful must be destroyed and its components recycled. This does not imply, however, that if industrial production keeps increasing at the rate it has over the past 50 years, there will never be a day when the planet's natural resources are insufficient to support it. Yet, there is another option that is relatively simple to conceive about, but much more difficult to implement. If the planet's mineral resources run out, just start seeking for them outside of Earth, in space. Large space stations mining resources from far-off moons and mining colonies on other solar system planets may appear like a classic science fiction scenario. But someone on Earth already thinks that this possibility is not so far-fetched, and they are investing staggering quantities of money on what will undoubtedly be the next great frontier in science, technology, and society, the colonization of space and the extraction of its mineral resources. Yet when we have an entire planet at our disposal to mine, why would we venture into space to search for rare metals on uncomfortably small celestial entities like asteroids? The cause, aside from the gradual scarcity of materials we have already discussed, is that gravity caused all the heavier elements to sink into the center of our planet while it was still in a state of fusion. As a result, the Earth's crust was completely depleted of all metals until an actual asteroid bombardment, which took place between 4.1 and 3.8 billion years ago, brought all the minerals we still mine today back to the surface. These minerals are crucial for our economic and technological advancement, but they are becoming more and more elusive. Except for those that are planetary in size, gravity has little effect on asteroids. The heavy minerals we're seeking for, however, are likely someplace near to the surface and are therefore simple to find and extract because of the numerous impacts they have endured and the fragmentation to which they have been subjected. There are three primary categories of asteroids that are currently recognized. Asteroids of Class C, or chondritis, are often carbon-based, black, porous, and rich in water. They are among the most expensive asteroids. In addition to serving as a food source and a highly effective radiation shield, this resource is essential for astronauts. The majority of the asteroids in the main belt are of type S, which is more prevalent and comprises asteroids that are typically denser and primarily made of silicates. Moreover, they are abundant in platinum group metals, ruthenium, rhodium, palladium, osmium, and iridium. Also type M, somewhat more uncommon but made up of asteroids with high metal concentration. Just to mention, the asteroid UW-158 has a diameter of approximately half a kilometer and is thought to contain valuable metals worth over $5 trillion, according to estimates. It flew close to the Earth in 2015. To choose the best targets for a mining mission, it will be important to identify between the three types quickly and effectively. Sadly, other from a few samples that have been reported to us from a few missions, the only technique we have to determine the makeup of asteroids is to examine fragments that have come to Earth as meteorites or analyze the light reflected from their surface. The spectroscopic observations are related to the exterior layer of the asteroid, which is exposed to space and vulnerable to various processes that change its composition. Therefore, these methods have significant limitations. Although meteorites are important, they only provide a partial picture of the events, since it's possible that the asteroid's most delicate constituents were destroyed as they traveled through the atmosphere. Finding families of asteroids, groups of asteroids formed by the fragmentation of one or more common ancestors, which can be used to identify groups with similar internal compositions, is another way for categorizing asteroids. The optimum method for excavation in the absence of gravity and the lack of knowledge about the uniformity and thickness of the layer of regolith of asteroids persists despite the identification of the best targets. What equipment will be required to remove elements from them? Our solar system is thought to include tens of millions of asteroidal objects, ranging in size from 10 meters to roughly 1,000 kilometers. Of the more than 15,000 objects known as NEOs, near-Earth objects, that have been detected and cataloged for their feature of dangerously approaching the Earth, it is obvious that we will need to select the best targets, at least for the first time. The technology required to deliver asteroid resources into Earth orbit will undoubtedly also enable the development of techniques to divert asteroids at high risk of impact. In practice, NEOs constitute both a hazard and a resource. But how many asteroids could be prime locations for mining? In order to determine how many asteroids would be suitable for mining with existing technology, Martin Elvis, a Harvard University astronomer with an interest in asteroid mining, created an equation in 2013. The equation accounts for the number of asteroids that can be reached by modern rocket ships, their likelihood of being valuable for extraction, whether doing so would be technically feasible, and whether doing so would be profitable. Around 10 potentially metal-rich asteroids and 18 suitably water-rich asteroids, according to Elvis's initial analysis of the data in 2013, are within our reach. All simple, then? Really not. Presently, asteroids mining is viewed as a wholly speculative endeavor whose quick adoption is hampered by prohibitive startup expenses. Despite this, an increasing number of private businesses are forming specifically for the goal of prospecting, exploring, and extracting asteroids, indicating that this fantastic concept is now moving from the realm of science fiction to the world of scientific facts. Naturally, asteroid mining businesses must first persuade potential financiers that a project of this nature is viable and feasible, and that work is already under progress. Deep Space Industries was created in 2012 after Planetary Resources, the first business ever. Several other ones have already been produced, and while some are undoubtedly less dangerous than others, it can be stated that the race for the riches of space has now officially started. One day, businesses like this will deliver metals for electrical devices and catalytic converter production to Earth, as well as minerals that will be converted into rocket fuel or materials for 3D printing space constructions. But many believe that all of this upheaval won't change anything until the economy based on human presence in commercial orbit gets off, space stations, permanent bases on the moon, etc. A market won't start until then. The market will only then spontaneously develop the technical capability to access NEO resources. In other words, we are in the midst of a new Klondike, a gold rush that might bring in 12-figure profits, to put it mildly, thousands of billions of dollars. But this time, having a flexible mindset, strong arms, and shovels won't be enough to succeed. Certain spacecraft will need to be designed, built, planned reconnaissance flights, surveyed, and transported to our planet, and, if a human crew is anticipated, sufficient astrominer training will need to be provided. All of this requires significant financial and human resource commitments, as well as a great deal of foresight, and is not something that just happens. For its part, NASA has already expressed a genuine interest in this field and has already presented the new Asteroid initiative, which calls for selecting an asteroid that can be captured, moved into an orbit halfway between the Earth and the Moon, and then physically studied by astronauts. But if the West is making progress, China has already made some headway. Asteroid extraction robot dubbed NEO-1 will be sent into orbit by a private Chinese business called Origin Space. It will launch on a Long March rocket supplied by the China National Space Administration in an effort to entice private businesses to begin mining space resources. The robot will be utilized to test the procedures and technology required to arrive on an asteroid, find and catalog the materials, and then begin removing them. Moreover, to mimic the capture of tiny asteroids, how long will it take to see the initial findings? How much time will pass before a space tugboat transports a stunning mountain to our house in lunar or planetary orbit? Without a doubt, not in the 10 or 20 years that private corporations have been advertising.